Yeah, be cool, just move with the groove. No funk in here, the beat way too slow.
Hello, I'm going to show you how EasyTruing works. Well, the device, I have it on my hands, you can see it. It contains a finger that travels in and out, and at the end of the finger there is a wheel that turns when put in contact with the rim of the wheel. Well, it contains an internal electronics and a display, a set of LEDs, red on the left, red on the right and green in the middle, and a small keyboard. At the back there's a guide that is useful to insert it into any Truing stand. Well, to insert it into the stand, one like this for example, we just have to slide it and turn the nut. Well, this is installed. Well, the first thing we have to do is to power it. We now are powering it externally because this is a prototype. The final version will contain an internal battery. Well, as soon as it powers on, it starts giving us instructions here. Well, the first thing I have to say is that this is an instrument that can work as a standalone device, and just with this we would be able to do the Truing. But there is an extension that is a software that can run on a PC like this, for example. If you run
EasyTruing tool. Attach the tool and press K2.
well, the first thing that the software does is establish a Bluetooth connection with the device. Once the connection has been established, the device is communicating continuously with the PC. The same software is available for smartphone. Now in this demonstration I'm going to show both workings simultaneously. What I'm going to do is to record this screen on the PC, and from now you will see this screen inserted into the video. Okay? Well, let's see, the first thing we have to do is to insert this to put the wheel in contact with the rim. We have to half press, more or less, to allow travel to go in both directions. We see that the system tells us when the point is correct. Well, this is the point, and I just have to tighten the screw, the nut, underneath. Well, the system is in position. I now have to press this key.
Reading wheel. Turn slowly.
Well, the system now tells me that I have to do at least one complete revolution so that the system collects data from the alignment of the wheel. We don't have to pay attention because the system will tell us when it has enough data.
Proceed with the Truing.
Well, from this point, the system has collected all the data from the wheel, made internal calculations to determine which are the good points and the bad points of alignment. And from this point, as I turn the wheel, we can see directly here, at any point here, the amount of deviation. If the LED is green, it means that the point is correct. It enters into a good area. Here we see that the red LEDs are starting to flash, telling us that here in this area we have a bad alignment. This same information appears on the screen, in the graph on the screen, so that is very easy and clear, because on the screen you are watching that there is a cursor that is moving along the graph. So that is very clear, the presentation of the information. Well, what we have to do now to make alignment is to go to the point here. For example, we just have one area of misalignment. We have to go more or less here to the point of maximum deviation, more or less here. And now we have to do something with the spokes that are here in this area. Well, here we are seeing that the LED goes to the right And here we have the amount of deviation and a minus sign and a plus sign. This means that the spokes that go from here to the left, we have to tighten these spokes. And if we move the spokes that are here, that go from here to the right, we have to loosen because we have a minus here. Well, if there is nothing abnormal here, I can touch any of these spokes on this area. If I touch this, as it goes to the left, I have to tighten it. I'm going to try, and in real time you will see on the one hand that here the LED goes slightly to the left, Here you see that the amount of deviation is decreasing, and at the same time you are watching on the screen of the PC that the point is going to the middle. Well, here you have reached the green point, almost zero deviation. This is 0.02 millimeters, it's 200ths of a millimeter of deviation, and on the screen at the same time you are seeing that we have introduced the bad point just into the middle of the screen. If I keep turning to refresh all the data from the closed area, well, you see that once the cursor disappears on the right, it rolls over to the left. Well, I keep turning, well, and I see that all the points now appear in green, and on the screen you see that all the points are almost flat and inside the red limit lines. Well, now the alignment is finished. And there is another thing that the software allows us. Well, I'm going to stop this. There is another thing that we can do is if I press this button, print, I can generate a report. This is especially useful in the case of a repair shop, where you can introduce here the client codes, name, etc. You accept, and it generates a PDF report that you can name and store it into the PC. Well, the report can look like this, where you can insert the logo, etc., together with the date, data, etc., and the graph of alignment, so that you can give this to your client. We have seen how to do the axial truing of the wheel with EasyTruing, but there's another feature that the instrument has. If I at any time press this key, a laser beam lights on or off. This laser beam. I can move the tool and point the laser beam to any point closer to the edge of the rim. For example, here I tighten the screw, and if I turn the wheel, I can check the roundness of the wheel, taking into account the distance from the point to the edge. This is important too.